So this is the problem number 14. The adjoint of differential operator ddx acting on a wave function psi of x for a quantum mechanical system. Okay, so the general formula we know that for adjoint operator, that is if we have an operator A, then psi star A phi dx equals to psi, sorry, A psi whole star phi dx. If any operator satisfies this relation, okay, then that operator must be an adjoint operator. Okay, so we have operator ddx. Let's check it. So integration psi star A is nothing but ddx, so d phi dx into dx. Let's do this integration using by parts method. So psi star phi integration will be limit will be there, then negative sign, then integration psi star, so it will be the first derivative of the psi star, so d psi star dx into integration of it will be phi again, then dx. Okay, now at the boundary it gives 0, so minus integration d psi star dx phi into dx. Now it can be written as, so integration minus d dx psi, we can take whole star here, then it gives phi into dx. So if we compare these things, whole things with this, then you can easily say that that what is the adjoint of this operator. Now leave it here. Okay, from here we can also compare. So what will be the adjoint of this ddx? Now ddx adjoint of this operator is nothing but minus ddx. Okay, so this will be the answer, only minus ddx. Next, two operators are given, p and q. We have to find out this commutator. So to find this commutator, we have to check it with the help of option. So let's start from option A. Okay, so q inverse, then pq. So commutator of pq is nothing but, uh, let's do directly. So pq is nothing but pq minus qp into q inverse, multiple it, q inverse p q inverse minus, sorry, it will be q inverse q p q inverse. It gives one, basically I identity matrix, q inverse p minus, it will be p q inverse. So it is nothing but commutator of q inverse p, but we have to find out commutator of what, pq inverse. So this is nothing but option this a, option a, this. So if we take pq inverse, now one negative sign will be there, so pq inverse is nothing but negative of option a, that is negative of q inverse pq commutator, then q inverse. So this is the exact answer, so option B will be the correct one. Now gamma is given. Next question, gamma is given, also m is given, okay, as 2 by 2 matrix form. So similarity transformation, we have to use similarity transformation so that m transform to gamma can be performed. Okay, now we have to find out the transformation matrix, okay, so that we can transform m to gamma. Like here, if a matrix a can be can be a can be built with the help of another matrix B by the similar transformation P B P inverse. Okay, so here we have to transform M to gamma. So gamma will be P, then M, then P inverse. Now we have to find out this transformation matrix P. Okay, so to find this transformation matrix P, we have to find first the eigen values of M as well as the eigenvectors of M. Then we can easily build the transformation matrix. So let's find the eigenvalues of this matrix. So eigenvalues of matrix M. So 10 minus lambda into 2 minus lambda minus 3 iota into minus 3 iota. So it gives uh, 9, I think, equals to 0. Okay, so uh, it will be 20 minus 12 lambda, then plus lambda squared minus 9 equals to 0. So lambda squared minus 12 lambda plus 11 equals to 0. We can find the eigenvalues here, that is lambda 1 and lambda 2. So lambda will be 12, then plus minus root and 12 squared 144 minus 4 times AC, so it will be 44 divided by 2 only. It gives 12 plus minus uh, it will be 100, so 10 divided by 2, so answer will be 1, another one is 11. Okay, so these are the lambdas value. So corresponding these two lambdas, we can easily find the eigenvectors for lambda equals to 1. For lambda equals to 1, what will be the eigenvalue vectors? So for lambda 1, 10 minus 1, there is 9, 9, then 3 iota minus 3 iota, 2 minus 1 is 1, x1 x2 equals to 0 and 0. So the relation we get 9x1 plus 3 iota x2 equals to 0. So 3 iota x2 equals to minus 9x1. So from here we can easily find that x2 is nothing but 3 iota x1. Okay, so again vectors will be 1 and 3 iota. This is for lambda equals to 1. Similarly, if we want to find for lambda equals to 11 here, we can find that this will be minus 1, 3 iota minus 3 iota, then it gives 2 minus 11, that is nothing but minus 9, then x1 x2 equals to 0. So from here we can easily find that x1 that is x1 equals to 3 iota x2. So matrix or matrix will be uh, 3 iota 1. Okay, so ultimately we get that P matrix here. So transformation matrix will be eigenvectors of these two. So 1 3 iota 3 iota 1. If we want to normalize it from here, then 1 divided by root 10 will be there, 1 divided by root 10 will be there, sorry, it will be root 9 now, root under this 1 squared plus 3 iota squared, so it will be 10, only 10. Okay, 10 only. So 1 squared 3 squared, so it gives 10. We have to take mod for this case, so it will be 1 by root 10, 1 3 iota 3 iota 1. So option A will be the correct one. Okay, for question number 16, A will be the correct option. Next question. Consider the Hamiltonian. Hamiltonian is given at any time t. Okay, then we have to find the time dependent function also given, beta t. Beta t, this time dependent function beta t. So beta t is given as alpha when t less equals to 0 and 0 when t greater equals to 0, greater than 0. Okay, now find the part, we have to find psi of t 0, sorry, t less than 0, psi of t less than 0 psi of t greater than 0 t greater than 0 then mod squared. So we have to find this probability value. Okay, so we have to initially build that wave function, then we can go for finding the probability na? So psi of t t less than 0, that is basically normalized ground state wave function. Normalized ground state wave function. Now if you see, then you can see that the given Hamiltonian is addition of two part. One part is the time independent, that is we can say the initial part as h naught, and another one part is the time dependent. Okay, very simple. Another part is the time dependent part. Okay, so if we consider t greater than 0, then beta gives 0 value, and if we consider t less than 0, beta gives some value. So let's consider t less equals to 0 case. For t less equals to 0 case, what will be the ht value? For t less equals to 0 case, what will be the ht value? T less equals to 0. So here we get alpha 0 0 0 2 alpha 0 0 0 3 alpha. Okay, and for t less equals to 0, beta of t is given alpha. So here we have to add this term 0 0 alpha 0 0 0 alpha 0 minus 2 alpha. Okay, add these two matrix, so it gives alpha 0 alpha 0 2 alpha 0 then alpha 0 then alpha. So this is the matrix. So it gives us alpha into 1 0 1 0 1 0, sorry 0 2 0, then 1 0 1. This is the Hamiltonian when t less equals to 0 case. Okay, so this is the Hamiltonian for t less equals to 0 case. Fine. So what will be the eigenvalues for this case? Because psi of t less than 0 case, this is the normalized wave function for the ground state. Okay, so we have to find the eigenvalues for this Hamiltonian, then corresponding the minimum eigenvalues, that will be the ground state. Okay, so if we want to find the eigenvalues for this state, this Hamiltonian, so it gives, so let's find the eigenvalues corresponding first row. Okay, so first row it gives 1 minus lambda, alpha also there, so we can neglect alpha here, so both side we can neglect. Okay, we can ignore the alpha value here. So 1 minus alpha, sorry 1 minus lambda, 2 minus lambda into 1 minus lambda. Okay, so this is the things, 1 into this minor, then for this case it gives minus 1 minus it will be only 2 minus lambda. Okay, it will be 0. So 2 minus lambda into 1 minus lambda into 1 minus lambda squared, 1 minus lambda squared minus 1 equals to 0. So 2 lambda equals to 2 is there, and it will be satisfied when, again from here also we get one lambda, another lambda is 2, and another one is lambda equals to what? Lambda equals to 0. Okay, so there are 3 lambdas, since it is 3 by 3 order Hamiltonian. So lambda is 2 is the degenerated state, and lambda is 0. So lambda is 0 is the minimum energy eigenvalue. So eigenstate corresponding this minimum eigenvalue will be the lower energy state, that is the ground state. So corresponding this lambda equals to 0, we have to find the eigenstates. Okay, for this Hamiltonian. So what will be the vectors corresponding this state, eigenvector will be, if we find the eigenvectors for this lambda equals to 0 case, then you get 1, we have to multiple 1 minus 1 0 1, then 0 2 0 1 0 1, that means h minus lambda, okay, into that eigenvectors x1 x2 x3, and here 0. So if we compare both sides, then we get x1 plus x3 is 0, and we can substitute x2 as 0 here, because 2x2 is 0 na, 2x2 is 0, so x2 will be 0, and x1 equals to minus of x3. So the matrix will be that ground state, that xgs will be 1 0 minus 1. This will be the state, okay, this will be the ground state. Now if we write the state for the t greater than 0, so this is for what, this is for t less equals to 0 now, so this is the case for t less equals to 0. Now if we want to write the states for t greater than 0, so for t greater than 0 the beta value will be 0, so only this only this will be the Hamiltonian. Now this can be write as like alpha, so 1 0 0 state, let's take as this k1 state, okay, then 2, if we take common out 2, then 2 alpha, then 0 1 0 state, so 2 alpha, this is the state 2 0 1 0 state, this is the one state, that means 1 0 0 state, then 2 state k2 is nothing but 0 1 0, and third state is 0 0 1 state, so can we write 3 alpha into k3, okay. So this is the basis when t greater than 0 case. So can we write this state, that the ground state, in the basis of 1 2 and 3, k1 k2 k3 we can write, okay. So it will be this is k1 is 1 0 0, so 1 0 0 k1, and 0 0 minus 1, so 0 0 minus 1, we can write that minus of k3, since k3 is 0 0 1, so minus of k3. If we take, this is the state, and if we normalize it, then in front of it we have to multiply with 1 divided by root 2, so this is the ground state ultimately. So this is the state when t less equals to 0 case, and obviously this is the ground state, okay. Now this is the ground state, so now we have to find these things, we have to find the probability, okay. So for t less than 0 case, we get the function, we get the wave function. For t less equals to 0 case, for t less equals to 0 case we get the function, and for t greater than 0 case, less equals to 0 case, that means at t equals to 0 the wave function is this, at any time t, then we know that how to write any wave function from t equals to 0 to at any time t. So psi of t, that is when t greater than 0, we can write it like this way, that is 1 by root 2 1 e to the power iota ent by h cross iota en. So energy will be the energy, what will be the energy corresponding this one state, so corresponding this state energy will be what, energy will be 1 0 0 state 1, so 1 t by h cross, okay, then minus k3 e to the power, so for k3 this function is 0 0 1, so corresponding this state, what will be the eigenvalue, that is the 3, so minus 3 iota t by h cross, minus 3 iota t divided by h cross, and there is also alpha, okay. So eigenvalue will be here alpha, here 3 alpha, so alpha will be there, alpha iota t by h cross 3 iota alpha t divided by h cross, okay. So this will be the wave function at t greater than 0. so k top this. So now we can remove the first part to solve the remaining one. Okay, so we have the states psi of t less equals to 0. Okay, so this is the state 1 by root 2 1 plus 3. Okay, and also we have the state t greater than 0 case. It will be 1 by root 2 k to 1 e to the power minus iota alpha t by h cross minus 3 to the power minus 3 iota alpha t by h cross. Okay, so take this product, inner product, that is psi of t less than 0, psi of t greater than 0. Okay, so take this inner product, so 1 by 2 will be here, and 1 1 is 0, inner product of 1, sorry, inner product of 1 1 will be 1, 3 3 will be 1, and 1 3 or 3 1 will be 0. So that's why only the exponential term, this exponential term will survive. There is no cross product with 1 and 3. Okay, so 1 1 will be only there, or 3 3 will be there. So it will be e to the power iota alpha t by h cross, then minus minus plus e to the power minus 3 iota alpha t by h cross. Okay, so this is the things. Now if we take common e to the power minus iota alpha t by h cross, or we can also take common e to the power minus 2 iota alpha t. Okay, so if we take 2 iota alpha t by h cross common out, then it will be e to the power plus iota alpha t by h cross, and this one will be e to the power minus iota alpha t by h cross. So then take mod squared, so that is the probability. So psi of t less than 0, psi of t greater than 0, taking mod squared. So if we take mod, then it will be e to the power plus iota. Okay, both are cancelled each other, mod, so it will be 4. Then here, and this part is basically cos of, that is e to the power I theta plus e to the power minus I theta, that is the by divided by 2, that is the cos theta. So we can replace here, that is cos alpha t by h cross 2 times, since there is no 2 in the denominator, so multiple by 2 and divided by 2, it whole squared. So 4 4 cancelled, so cos squared alpha t divided by h cross. So now we can replace this 1 by 2 cos square alpha t by h cross. So we know that the formula cos 2 theta, that is cos square theta minus sin square theta equals to cos 2 theta. So we can replace 2 cos square theta. So 2 cos square theta is nothing but 1 plus cos 2 theta. So 1 by 2 1 plus cos 2 alpha t by h cross. This will be the answer. 1 by 2 into 1 plus cos 2 alpha t by h cross. So here we can take h cross as a 1, and then option 1, yeah, 1 will be the correct one. Next, so psi of x is infinitely differentiable function, and then you have to find this operator value, and d is given, operator d is given. So firstly, what are the infinitely differentiable function? That means we can differentiate function infinitely, and it gives finite value. like e to the power x. So if we take infinite derivative, then it gives e to the power x. Okay, and again if we take derivative of any trigonometric function like sin x or cos x, it gives sin x, take derivative cos x, again if we take derivative it gives sin x. So ultimately it gives a finite value if we take a huge number of derivative, infinite number of derivative. And another thing is the normal polynomial of x, like x. So if we take derivative of x, it gives 1. If we take the derivative of 1, it gives 0. And if we take the derivative of 0, it gives 0. So it is also an infinitely differentiable function. So in general, we can take e to the power x also here, but for uh, simple calculation here we take this type of polynomial like x or x square, like that. That is in general, for simple cases, the infinitely differentiable function in the general form of the infinite differentiable function is basically polynomial of x, like f of x is summation k ak then x to the power k. So this is the general form, simple general form of infinitely differentiable function. Now here d, that is the operator that is given, and d psi of x we have to find. Okay, so d psi of x, replace d with the exact form ax d dx into psi x. Okay, fine. Now we can expand the exponential part here, so we can expand. So let's expand it. First term is 1. Here 1 means since it ddx is an operator, that's why we have to write here identity matrix I. Then plus ax ddx. Second one is 1 divided by 2 factorial. Here 1 factorial is there, and again ax ddx into ax ddx and so on, whole into psi of x. Fine. Now let's take psi of x as a trial as x. Okay, since infinitely differentiable function, we have to take psi of x as infinitely differentiable function. So let's take psi of x as x. So what will be then the expression? So d psi of x, if we replace psi of x as x, so I is there, then ax, if we differentiating first order derivative of psi of x is d psi dx, so psi is x, so it will be 1. So plus ax plus 1 by 2 factorial. First derivative is what? Operate this on psi of x first. So ax and then d psi dx. So d psi dx 1, then only ax will be there, and the remaining part the same way. So here I, so okay, psi will be here 1. So I psi plus ax, not psi, x will be here. We replace psi as x now. So ix will be there, then 1 by 2 factorial. So here if we derivative this, then it gives only a, so it will be a squared x by 2 factorial. Okay, now we can take x as common for every term. So I plus a squared by 2 factorial dot into x. So this is nothing but e to the power a. So e to the power a into x. So x is what? So e to the power a psi of x. Okay, now one option is there, option D, but we cannot sure that option D will be the correct one, because we, since e to the power a is a constant term here. Okay, now e to the power a into psi of x, also we can write this term as psi of e to the power ax. Okay, also psi of e to the power a into x is also there in option. Okay, so to confirm what will be the correct one, we have to check with the higher order x value as psi of x. So let's check psi of x for x squared. So for x squared case, we can again find the d psi of x value. So first term will be I x squared. Okay, second term will be first order derivative of x, x squared, that will be 2x, to 2 into a into x squared. Okay. The third term will be 1 by 2 factorial ax d dx. So first order derivative of x squared, it gives 2x, so it will be 2ax squared again, and so dot 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 dot. Okay, so I x squared plus 2ax squared plus 1 by 2 factorial. Now here 2a is common out, so it will be 2a squared, and again derivative of x squared will be 2x, so 4a squared into x squared, 4a squared x squared, and so on. Now we can write this term, as let's take x squared will be there na, take x squared as common, we can common x squared here, so it will be I to the power 2a. Okay, so if we take common x squared, then the remaining part will be to the power what, 2a. Okay, now this term can be written as x into e to the power a whole squared. So we can see easily that this is nothing but psi of x e to the power a. So which one will be the correct one? Option C will be the correct one. Okay, next two eigenvalues of matrix are given, and what will be the third eigenvalues? We can find easily, because what will be the trace will be a plus 2 plus 1, that is addition of the eigenvalues. So two eigenvalues is given, 1 minus 1, so another eigenvalues, let's take b, so b will be the another one, so 1 minus 1 cancelled, so b will be 3 plus a. Okay, fine. Now let's find the determinant of it. So find the determinant about this row. Okay, so determinant will be 2a minus 9. Now determinant is also the multiplication of the eigenvalues, 1 minus 1, and another one is b, so it will be minus b. So from here we can say that b is nothing but 9 minus 2a. Now replace here b value, so 3 plus a equal to 9 minus 2a, so 3a is nothing but 6, a will be 2. Now from here we can find the b value, 3 plus a, that is 2, so b value will be 5. So third eigenvalue will be 5, option b. Next, canonically conjugate operator x and y. Xy is given, commutator value, and the expression of x and y is also given, and q1 and q2, commutator of q1 q2 also given. So we have to find out the alpha 11 22 minus alpha 12 alpha 21 value. So we can solve it easily, because very easy, but it looks like very difficult, very easy thing. So let's find the okay, so let's substitute x and y here in the first commutator relation, that is x cap y cap equals to iota h cross I. So replace the given value, so we can replace here within the commutator, alpha 11 q1 operator plus alpha 12 q2 comma alpha 21 q1 plus alpha 22 q2. Okay, that is equals to iota h cross I. Okay, now according to the commutator relation rules, so we can commute with the we can relate q1 with q1 here, and q1 with q1 here, and also q1 with q2 here. So here we can break the commutator bracket, alpha 1 alpha 11 q1 with alpha 21 q1. Okay, first term, second term will be alpha 1 1 q1 plus alpha 2 2 q2, fine, sorry, comma, then plus third term will be alpha 1 2 q2 with alpha 2 1 q1, okay, fourth term alpha 1 2 q2 then alpha 2 2 q2, okay, that will be equals to iota h cross I, fine. Now we can take common out since alphas are constant value, so q1 q2 q1 q1 it commute, so it will be 0, and similarly for q2 q2 it's also 0, so only the remaining term are there here. There is alpha 1 1 alpha 2 2, it can common out since they are constant term into q1 commutator of q1 q2, okay, and plus alpha 1 2 alpha 2 1, so q2 q1. Now given that the commutator of q1 q2 is nothing but zi, so what will be the commutator of q2 q1? So nothing but negative sign will be here, z to I, so replace that value, so alpha 1 1 alpha 2 2 then minus alpha 1 2 alpha 2 1 equals to sorry into whole into commutator of q1 q2, that is nothing but z into I, that is equals to iota h cross I divided it, so the answer will be iota h cross by z, okay, option B. Next psi of x is given, just differentiate it, okay, sorry, integrate it, so f of k is given 0 for k k mod of k greater than k by 2, and it is alpha yeah it is a when mod k less equals to k by 2, so mod of k less equals to k by 2, that means k runs from minus k by 2 to k by 2 plus k by 2, okay, so let's find the integration value, just integration, so minus infinity to plus infinity, so f of k then e to the power iota kx then dk. Now within minus k by 2 k by 2 to k by 2 the function is valid or function is defined, so we can just only integrate it minus k by 2 to plus k by 2, that is a iota kx into dk, just integrate it and substitute the value, it gives a divided by iota x then e to the power iota k x by 2 minus e to the power minus iota kx by 2, okay. Now if we divide it by twice iota 2 by x, it gives sine of kx by 2, okay, so this is the things. Now we have to normalize it, so this is the wave function ultimately we get, so to normalize it we have to integrate it minus infinity to plus infinity and equal to 1, so minus infinity to plus infinity psi star psi, so it will be what 4a squared sine squared of kx by 2 divided by x squared d, I think it will be dk equals to 1, so 4 is a squared. Now we can replace kx by 2 as what, so let's take kx by 2 as t, so dx will be dt by k, okay. Now replace it, so minus infinity to plus infinity sine squared t divided by x squared is nothing but 2t, so 4 by k squared into t squared, okay, into dk is replaced by 2 by k into dt equals to 1, so from here 4 cancelled, so only 1k, so it will be what, it will be a squared, sorry, a squared k 2a squared k, 2 is here, 2a squared k minus infinity to plus infinity sine squared t divided by t squared dt, okay. This is a standard integral, so it gives pi value only, so a squared will be 1 divided by 2 pi k, so now we can replace a here, that is 2 into 1 divided by root over twice pi k and then sine of kx by 2 by x, so it will be what, root under 2 divided by pi k into sine of kx by 2. This will be the answer. Option B, I think, pi k by 2. Both options are correct. Option D are the same option. So option, let's take B. Again, another question. A and B are such that A plus B n cross n matrix, obviously A plus B is invertible. Invertible means mm, uh, the inverse matrix of this matrix will exist, and also if we take the product then it gives identity matrix, like same, sorry, A will be A inverse. That is the condition of invertible matrix. Okay, so A plus B inverse is A plus B. Okay, and second line is the defined two matrices A, C and D, which are, or okay, what relation are, which relation is true for this case? Okay, fine. C and D. Okay, so for in case of C, now we can say A into A plus B inverse into B. Okay, now A plus B inverse is A plus B, so A into A plus B into B. Okay, so it will be A B plus A B B. Now we can exchange the orient that sequence. So if we first uh, take this A in front, it will be negative. Again we can take in front of A, it will be positive. Okay, fine. So using this method, you can rearrange it with D. Okay, so let's take B in front of both A. So if we take B here, A B A, then one negative sign will be there. Again if we take B in front of this A, it will be positive. So B A A, and same case, let's take A here, then it will be negative, so negative B A B, and again B B A, it will be positive. So B B A. Now take common out B first, it will be A plus B, and B last. So sorry, A will be there. So this same as D. Okay, since A plus B is A plus B inverse, so B into A plus B inverse into A. So option A will be the correct one. C equals to D. Next, A is Hermitian. So A dagger. Hermitian means what? Hermitian means A dagger equals to A inverse. Okay, that is the Hermitian. Okay, and for C and D are unitary. Sorry, A dagger equals to A, that is the Hermitian. For unitary, C dagger equals to minus C inverse, and D dagger equals to D inverse. So that is the unitary matrices. Now which of the following matrices is unitary? We have to check using option. So let's check, consider first option. So C inverse AC, take dagger, so C dagger, A dagger, then C inverse dagger. Okay, C dagger is what? C dagger is C inverse. A dagger is what? A dagger is A, since it is Hermitian. Then we can shuffle this operation. First take dagger, then take inverse. So dagger, C dagger is what? C minus, again minus, so it will be C. So exactly same. That means option C, if we take this is E, then E dagger is nothing but E. So it is Hermitian matrix. It is not necessary that Hermitian matrix, that means Hermitian is also unitary. It is not necessary. So option, we cannot say that option A will be the correct one. So next go for option B. So C inverse DC, take the dagger, both dagger, C dagger, D dagger, C inverse dagger. Okay, so C dagger is what? C dagger is C inverse. D dagger is what? D inverse. Okay, fine. And if we take the dagger in again invert, then it will be only C. no relation. So simply this is the inverse, sorry, this is the dagger one and this is the exact one. So let's take product. That means if it is E, then E dagger is this, so E into E dagger. If we take E into E dagger, so E is this, so C inverse DC into E dagger is nothing but this one, C inverse D inverse C. If we multiple C into C inverse, what identity 1, again D into D inverse 1, and C into C inverse again 1, so it will be I, that is the unitary matrix. So obviously option B will be the correct one. Which is the unitary? Option B is the unitary matrix. Okay, next, given a 2 cross 2 matrix 1, 13, 0 and 1, we have to find the a to the power 27. So let's find the a squared first. 1 0. So this, for this type of question we have to find the pattern. Okay, if we crack the pattern, then we can see easily, or we can write easily what will be the power, what will be the a to the power 50, what will be the a to the power 100, what will be the a to the 58. We can easily predict that. So let's find a squared. 113 01 into 113 01. Okay, so using this rule, that is row column row, so we have we take the multiplication of column row with column and write it as row. Okay, so 1 1 13 it will be 1, then again 13 plus 13 it will be 13 plus 13, so 26, then 0, then 1 again, so it will be 1 26 0 1. So let's take a cube, 1 0 13 1, then there is 1 0 26 1. So take product, 1, it will be 26 plus 13 0 1. So can you see the pattern? So here for squared, uh, this is the addition of 213. For cube, this is the addition of what? 13, 26 is 13 plus 13, addition of what? Addition of 313 for a cube. So we can crack the pattern easily here. That is, here it will be what, 4 times, sorry, it will be 3 here. This is the 2 times 13. Okay, that is 26. Here we get 39. Okay, so 39 is what? 3 times 13 is 1. So what will be for the value for 27? A to the power 27. So a to the power 27 will be 1 0 13 into 27, then 1. So let's find the value. 13 into 27, 13 into 27. So 13 into 27 gives us 3511. So option D will be the correct one. Next, n cross n Hermitian matrix A is not multiple of identity matrix. That means A is not multiple, like let's take lambda into I. It's not. Okay, if A equals to lambda, then the problem will be the different. But here the statement is given A is not multiple of identity matrix. Now which one of the following statement is true? Okay, so trace. So let's find trace of A. So trace of A, what is the trace? There is a lambda I summation of. Now if we take A squared, trace of A squared, so trace of A squared is nothing but summation of lambda squared. Okay, now if we multiple that n into trace of A squared, then it gives n into summation lambda squared. Okay, and if we take square of this, so summation take square, that is trace of A whole squared, it gives what? Summation of lambda squared, sorry, whole squared. Now see, if lambda i's are same, see very carefully, if lambda is the same, okay, so in what is the n is the order of the matrix. If we have 3 cross 3 matrix, that is n equals to 3, then we obviously we have 3 eigenvalues. Okay, we have 3 lambdas. So for, in case if all lambdas are same, that means if we can write the matrix, Hermitian matrix is a multiple of the identity matrix, for that case we can easily say that this n times trace of a squared is nothing but the trace of a whole squared, because if it is n by n matrix, then there will be the n lambdas, so addition of n lambdas with the same eigenvalues, with the same lambda values, addition of this, it always gives n lambda for same lambda. So n lambda is nothing but, if we take the square, it gives n square lambda square, and from here